Hey guys, this is video 8.6, our last video for our unit on stoichiometry. This is dealing with percent yield. So as I get to our page here, which again might be a different page number than what you have, this is going to be using again that same gram to gram method that we've been using. It's just a little extension beyond it. The good thing about it is that it's a percentage, and we've calculated percentages many times. Do you guys remember, think back, what is our generic formula for any percentage? Hopefully you remembered part over whole times 100, okay? So anytime you're calculating a percentage, except for percent yield, or not, sorry, percent yield, percent error is a little bit different, but any other percentage, it's always part over whole. So the part that we're talking about here is our actual yield, how much actually was formed from doing a reaction, and then the theoretical yield is what we calculated. So this is how much is formed from a reaction, and then the theoretical yield is calculated. Okay, so if you think about this in terms of your chalk lab, okay, our actual yield is what you found, how much chalk was produced after it dried out overnight, and then you guys went back and got the mass of it and subtracted your filter paper. The theoretical yield is what you calculated, okay? So the theoretical yield is the maximum amount of product. So if you think back to our last video, the maximum amount of product is dependent upon what? All right, and this goes back to 8.5. What determines how much of a product is formed? Your limiting reactant. So in your lab, just a little side note, you've got to figure out what your limiting reactant is first. That will dictate what your theoretical yield will be to then figure out your percent yield. Okay, so again, theoretical yield, guys, is calculated. Okay, you have to do a calculation to get this. It's a gram to gram problem. Like I'm telling you right here, it's in the notes. Make sure you read your notes and use it, because that's where people are going to struggle the most with this. Whereas the actual yield is what's actually produced of your product. It's from a lab result. So this is going to be given to you in a problem, okay? So how much is produced, that's your actual yield. You have to calculate the theoretical. And all you're doing is just a gram to gram problem with the reactant that they give you, all right? So let's jump right in. It says if 75 grams of carbon monoxide right here reacts to produce 68.4 grams of CH3OH, what's the percent yield? So this is our actual result of what was produced from running the experiment, okay? So that means we already have half of what we need, okay? For our percent yield problem, percent Y equals actual over theoretical. Bam, this is what's going to get plugged in right there. Okay, we have to figure out the theoretical, and that's what we're going to use this reactant starting material to find. So we're going to dive right in, 75.0 grams of carbon monoxide. We want to figure out how much product was produced from that starting material. Okay, so in a problem that you might see on the Regents, they're only going to give you really one starting material. Okay. In your lab, though, you have two starting materials. You've got to figure out which is the limiting reactant. So if you look through and you follow the directions on the lab and you kind of go through calculation 1 and then calculation 2 and such, by the time you get to this point, guys, it's going to you're going to have the work done. All right. So here we go. Grams of CO on the bottom, moles of CO on the top. Grams are gone. Moles of CO on the bottom. Moles of CH3OH on the top, because that's what we're trying to get to. It's the only product we have. And then moles of CH3OH on the bottom, and it would be grams of CH3OH on the top. Okay, and we're trying to end up with grams of CH3OH. Okay, so now start filling it in. Well, one goes there, one goes there. My mole ratio, I've got a 1 for CH3OH. I've got a 1 for CO, so that's pretty simple. Now I got to figure out my masses. When you get the mass of carbon monoxide, guys, it's about 28 grams, and the mass of CH3OH is about 32 grams. On your Regents, you guys would go to 2 decimal places. For the sake of this example, I'm just going to round it. So now when we do the math, we would get 85.7 grams of CH3OH. Okay? Now, you might think, well, I'm done at that point. Are you? Are you really done? What's the question asking you for? When you take a look, The question's asking you for the percent yield. Okay, so we've done the theoretical. We've done the work that seems like a lot. You think you're done at this point, but you've got to then go back and plug it into this formula. So our percent yield is the actual, which in this case was 68.4 grams of CH3OH, which was given to us. You at most, based on your starting material of 75 grams of carbon monoxide, could have produced up to 85.7 grams. So that's your theoretical. That's the amount that you could do if every single molecule reacted. You know that everyone's not going to. Some's going to get stuck to your container, and that's just the way it is. All right, so 85.7 grams of CH3OH times 100. And then we're going to do that math. When you do that math, guys, you should get about 79.8%. That's your final answer. All right, about 80% yield, which isn't bad. All right, you know, companies who are making, you know, products that they're trying to make money from, they're looking for like greater than 90%, so they're not wasting money. If you're in a research facility and you're trying to isolate a new compound, 80% is very, very, very good for a percent yield. So it kind of depends on the situation, but that's how we go through and figure it out. So I want you guys to pause the video, do the you try problem right here, then you can come back and watch me solve it for you in a minute or two. All right, so you try problem. Okay, we have 85.4 grams of Cl2 react completely according to the following reaction. It says if 104 grams of phosphorus trichloride is produced. So right here, guys, this is my actual. Okay, that's my actual. So maybe you want to label these things as you're going through that. We're looking for percent yield. So percent Y equals my actual over theoretical times 100. So the actual is already given to me. I've got to figure out my theoretical. So I'm going to use the other number that was given to me. So 85.4 grams of Cl2. Hey, look, I gave you the molar mass. On the Regents, they're going to probably give you the molar mass of compounds most of the time when you're doing a problem like this, just to save you time. Okay? So that's here. Grams of Cl2 go there. Moles of Cl2 on the top. Moles of Cl2 on the bottom. Moles of phosphorus trichloride, PCl3. And then mole of PCl3, grams of PCl3. So 1 mole, 1 mole. Let's take a look at my mole ratio. I've got 4 here, 6 there. My molar mass for chlorine was given to me. It's 70.91. My molar mass of phosphorus trichloride was given to me as well, 137.3. So now all I have to do is do the math. I can simplify a little bit if I want to. Again, remember, you don't have to, but I'm going to make this 2 and I'm going to make this 3. And then I plug it right in. When I plug it in, guys, you should get about 110 grams of PCl3. Now ask yourself, did I answer the question? Not completely. This is the part that I needed. This right here is going to let me plug into theoretical. This 104 is my, this 104 is my actual, okay? And now I've just got to do that last step. So percent Y equals my actual, which is 104 grams divided by 110 grams times 100. When I do that, I get a very good percent yield of about 95%. Okay? So, my hope is that you guys see, hey, this it's completely brand new. The idea and the terms are new, but the math, we've already done that up until this point. We've done percentages, we've done gram-to-gram problems. It's just a new application of it. So if you have questions, always feel free to ask in class. Make sure you go through and do the practice and stuff before you take your summary quiz, and I will see you guys in our next unit.